I'm Thomas Neeson, I'm Managing Partner at Cundall, and I'm delighted to invite you to the last of our current series of webinars. This is number 12 that we've done during COVID. And this one's a bit different to others we've done, which I'll explain in a second. Today's topic is the carbon assessment tool that we developed for the Construction Industry Council in Hong Kong. And this is showing how we can actually at a governmental level and an industry level, start to record the carbon we're putting into our buildings, how that might inform design and how that integrates into the overall piece of delivering a net zero carbon future. I'm very excited today because we're doing this completely differently. Our panel of speakers are in Hong Kong and they're in an office. And Natalie's in an office, so of our 5 panelists, I'm the only one that is sitting at home in my pajamas. Everybody else is being a professional. As people know, sustainability is the core of everything we do, and I think this one is a really good illustration of, we said, our cornerstones of sustainability, where we're looking at our homes and our projects, our communities, and our industry leadership. And this is a real piece of industry leadership that we have developed with CIC in Hong Kong and taken on to be now something that's been used widely in projects across Hong Kong. And our speakers will explain that it's been integrated into the assessment tools that mean it'll be much more widely taken up in the coming years, and I'll let them do that. So yeah, COVID still goes on. Hong Kong has returned more to normal. And talking to the team there, I know there's been a little spike in cases in the last few days. So our enjoyment of being back in our office there, which has been for the last 5 or 6 weeks, might be impacted. We have to wait and see in the days going forward. And all around the world, we're seeing different impacts. Our people in Melbourne have now been given another 6-week lockdown as cases spike there. And it probably won't be uncommon to see this in many parts of the world going forward. COVID will have a long tail. Today's speakers, if I can just introduce them, are Jonathan Yau and Helen Amos. Both work for Cundell in Hong Kong. Both have worked in our UK business at points in time. And got a wide range and experience in this subject. Jonathan's our Sustainability Associate Director in Cundell, Hong Kong, and leads our team. He's got over 11 years experience of both mechanical engineering, design and sustainability advice and consultancy, and this gives him a really, really practical background in how do we develop sustainable solutions on our projects going forward. He's delivered lots of projects across a real range of sectors, including healthcare, hotels, government buildings, residential, retail, commercial, the whole range of projects we get involved in. And yeah, his speciality is really integrating sustainable design into practical architectural and building solutions. Helen's a principal sustainability consultant in Hong Kong, and her expertise is embedding sustainability strategies with organizations and businesses as well as projects. She's worked in a whole range of sectors again, which allows her to apply her strong background in sustainability and environmental management systems and systems compliance to get really positive results for clients. So these two have been instrumental in helping us get this tool underway that we'll talk to you about this morning. So that's all I'd like to say about our speakers, give you an intro to them. Our talk today will again be about 30 minutes long. Again, the team want to give you as much information as possible, so they really pack it in, and they'll be talking at you at high speed to try and get their message across. Please raise your questions and answers as we go through. We'll pick them all up at the end. We're here to inform, but we also want to educate, but we also want to learn from the people that attend our webinars. So if you've got good ideas and questions, please bring them forward and we'll have a discussion about it all at the end. And if we don't get through your questions, we'll answer them by email. So without any further ado, I'll hand you over to our speakers. Enjoy the webinar and let's have some discussion right at the end. Okay, thank you.
Okay, thank you, Thomas. So I would like to start by introducing the company background. So Kundel is a multidisciplinary engineering consulting firm founded in UK in 1976. And we are now operating in 25 offices globally with just about 1,000 people. So sustainability is really the cornerstone of what we do, and we practice what we preach, and we're applying the sustainability principle in our projects, our offices, community, and the industry. So today we're going to talk about embodied carbon in design and construction, but in a nutshell, it's actually very similar to the way we manage energy efficiency in buildings. So, for example, in design stage, it's all about setting clear target, including embodied carbon in design process, optimize it, design it, and then include the necessary information in intent document. And when we move to construction stage, then it's slightly different. It's about getting the contractor to play their role and contribute, because quite often their contribution be underestimated by the industry. They can also play their role and have a huge impact to the project. They can optimize temporary works, improve site management, manage supply chain, and also faithfully construct a building. And finally, document the carbon emission and report it. So that's the approach generally when you talk about managing embodied carbon in design and construction process. So recently we could have been appointed by Construction Industry Council in Hong Kong. So they are the official councils setting lots of standards for the whole industry. So one challenge we found globally is that many people are looking at embodied carbon, but not often we get a industry-wide standard for the whole country or city. So this is exactly where it's coming from. Just trying to manage the embodied carbon in design and construction stage under the same common platform. So Helen, we're going to talk about more details when we move on a bit further. But essentially, using the same approach, we're now doing lots of embodied carbon consulting projects, from standard development, research propagation, tools development, engagement with policymaker, government, developer, supply chain contractor, and also doing trainings and project consultancy. So we are now working on this area just to help the industry to tackle embodied carbon. So now I'll pass the time to Helen to talk about more about the details of embodied carbon and how we exactly manage them in the process.
Hey, good morning, afternoon, everyone. Thank you very much for the introduction, Thomas and Jonathan. So I would just first of all start out, as Thomas said, this is actually the last in our series on webinars looking at embodied carbon or net zero carbon. So all our other webinars are available via our YouTube channel. So please feel free to go back and see the other ones where people have spoken about the other parts of it. And today, today I will just touch briefly on what net zero carbon buildings means. The World Green Building Council in 2018 initiated a roadmap to decarbonize the construction industry by 2050. The aim was to set targets and to kind of start and ignite people's journey. And at the end of middle of last year, they actually brought a document out called Bringing Embodied Carbon Upfront to really start to push embodied carbon, because up until that point, majority of the focus had been on the operational carbon and making buildings more efficient. But that actually forgets the emissions and the impact that buildings have in design and construction before they actually start operating. So around globally, the World Green Building Council are working to develop roadmaps to help organizations to start on that journey. And we are working closely in Asia Pac at the moment on the one that they're developing to try and drive embodied carbon, of which the actual carbon assessment tool has been really widely acknowledged as being a great step forward for the industry, and hopefully we can help others in the region be able to deliver the same results that we're hoping to see in Hong Kong. So our approach, or the route to achieving net zero carbon, we have kind of 7 key stages that we have developed within Cundall, looking at the various stages, and these have been previously discussed in our webinar. So please, if you're interested in any of the other stages, go to our page. But Today, I'm just going to focus on step 5, so limiting the upfront embodied carbon, so looking at the impact that our buildings have before they become operational, and how we can look to reduce those through design and construction. So what do we mean by upfront embodied carbon? There is the life cycle assessment, which is used widely, and it's not a new concept. But when we look at it in the process of the building life cycle, from the material extraction all the way through to the reuse and recycle and recover at the end of its life. So looking at how that building both is built and as well as it's used and what happens at the end. The key part, what we term upfront embodied carbon, covers the stages A1 to A5. This is looking at the raw material extraction, the transportation of those materials, the manufacture of the materials, and then actually the installation in site. A lot of life cycle assessment tools cover these stages as well as on the latter stages, but for the purpose of this presentation, we just look at the front end. And I think this aim is to demonstrate how embodied carbon is going to become more important and more influential in the long-term journey towards net zero carbon. Currently, energy globally is decarbonizing, and the grids the carbon intensity of the electricity grids are becoming less. When you look at the contribution of the built environment in terms of carbon emissions, 39% of those globally come from the built environment, of which currently around, or last year, sorry, in 2019, around 11% of those were actually from the embodied carbon, so the upfront. But while we decarbonize and make the operational carbon decrease, it only will increase the impact and the significance of embodied carbon over time unless we address it and try and do something about it. So this, as I said, life cycle assessment is not a new concept. There's many systems out there that look at creating look at tools that are able to be used for carrying out embodied carbon assessments, be it for both construction as well as other sectors. There is a new tool that was launched in beta version at the end of last year called EC3, which I haven't included on this slide, but it's one that's designed specifically for the construction industry and has the ability to have benchmarks. So it's expected that that will really help drive the industry forward globally at this time. So just to give a bit of background into what Kundel have done. So we actually are finishing up a project at the moment working with the Greater London Authority to help the implementation of the new London plan. So part of that plan requires all planning applications that are referred to the Mayor for approval to have had a whole life cycle carbon assessment carried out. So that's looking at the full life cycle. So more than just the upfront embodied carbon, but actually its impact in operation and decommissioning or disposal at the end. So we worked with this policy and this vision to create guidelines that can be used by the industry with methodologies and tools that could be used, as well as setting up benchmarks within that system that applicants can use. So this should really drive the industry to change within London. It's not published officially yet, but it's in progress as we speak. And then, as Thomas touched on, we've done this amazing industry-leading project in Hong Kong looking at the carbon assessment tool for the construction industry. So the tool aims to be a publicly available tool that anybody can use to look at the impact of projects. Within the tool, there is the ability for this Construction Industry Council of Hong Kong to be able to monitor and report the global impact of projects within Hong Kong, to understand what the impact of the construction sector is within the Hong Kong general carbon emissions, and then help to do reporting and hopefully set targets, reduction targets, etc., for the long-term vision of Hong Kong's long-term 2030 and soon to be probably announce its 2050 plan towards carbon reduction. The tool is designed to help the construction industry embrace embodied carbon and trying to reduce it through both design, specification, as well as monitoring everything within construction. The tool at the moment, it launched at the end of last year, and we have around 300 projects that have signed up to be using the tool so far. And as Thomas mentioned, we actually have managed to work with Beam Plus, which is the equivalent of BREEAM LEED in Hong Kong, to actually get the tool integrated within the requirements of one of the credit, or 2 credits actually, within the assessment. So we're hoping that this is going to really drive the industry to move forward, creating this common platform where everyone is reporting against the same, or reporting with the same information. So we can compare and contrast the performance of projects, and hopefully eventually, when enough data is available in the tool, set industry benchmarks for Hong Kong. So as I said, we only look at the upfront carbon. But what does that actually represent in terms of the tool and in terms of the whole life cycle carbon? So when we look at it, we are focusing on the superstructure, the substructure, and the facade. So what we term the core and shell for projects, along with the transportation of the materials and the on-site impact. So as this graphic shows from the Letty guidance that was published last year in London, she makes up more than half of the total whole life carbon. We deduct out, we don't actually cover MEP and internal finishes at the moment within our tool, mainly because the industry needed to start understanding and reporting its impact. And the materials that make up the substructure, superstructure, and facade are very common materials with standard specifications, which makes it easier for us to create a database and an ability for people to report. Also, our experience was that it's much harder to find clear information on the impact of MEP services and more internal finishes in terms of embodied carbon. So we felt that this is the starting point. And I think probably to explain that a bit more is the struggle that we had in Hong Kong is that we don't have a database currently in Hong Kong. So as part of the project, we had to work to develop that database. Hong Kong imports most of its construction materials except for concrete and asphalt, and we do also have a cement manufacturer, but most of the construction materials are imported. Therefore, we looked and worked with the supply chain to understand where these materials were coming from, using Hong Kong trade statistics over a period of time to understand where the materials were coming from so that we can get representative data rather than using a standard database. So we wanted to develop one that's localized to Hong Kong. So when we found out where these materials were coming from into Hong Kong, we then looked for product declarations where they weren't available, which total and give the information about the embodied carbon of a given product. We then look at international and regional life cycle databases. There is one in China, which we used heavily because a lot of materials are coming in from China, in mainland China into Hong Kong. We then did, for concrete, we had to do some calculations and looking at mixed types in Hong Kong and making sure that the concrete numbers were correct for Hong Kong, along with using the life cycle, carbon assessment tool that Hong Kong has for products. So we incorporated all of those, and then looking at the how the materials are getting to Hong Kong and how they're transported within Hong Kong as well. And then periodically this will need to be reviewed because we noted over the 3 years of statistics that we looked at for trade in terms of construction materials, there was differences depending on market rates. So we need to make sure that there's periodic reviews carried out. So how can we look at this in terms of design and what can we do? So the greatest saving potential lies in the design. Building less and building clever really does give us the opportunity to reduce the impact that the buildings have before they're constructed. So design optimization, therefore, is fundamental to how we go about looking to reduce the embodied carbon of projects. And as many structural engineers go about optimizing their design, there is many things they look at. And so this just means such as cost, buildability, structural performance. So we believe that the best way to be able to make embodied carbon a consideration is to actually include that at the front as well. So it becomes just another method of being able to rate the performance of a structure when you're comparing designs. So achieving reductions in embodied carbon, there's many ways to look at this through design and specification. So looking at utilization of different structural forms often can save resources and materials, so that can also reduce the embodied carbon early on, but still provide the same structural performance that's required. Looking at modular construction and off-site fabrication as a way of reducing the wastage. And also by going down these routes, you're able to look at different ways of designing as well. Looking at what's going to happen for the building in demolition. Although it's not considered within the CIC tool, this is something looking at how the building will be demolished or could be reused or reformatted in future usage is important upfront. Along with when it comes to specifying materials, looking at low carbon alternatives. We working on a project, and just actually changing the specification of the material actually can have a big impact on the overall embodied carbon of that project. So how we've used it, or how we're looking to use the carbon assessment tool in Hong Kong in our designs from a structural perspective, is looking at the materials quantities output from BIM or Revit models, which are obviously developed throughout the design process and provide a really key source of information. And feeding that information into the carbon assessment tool can give us an understanding of what the embodied carbon saving could be of changes in design form. Within the carbon assessment tool, there is the opportunity to actually compare options. So we can compare two design options and demonstrate the saving, and that can then become the baseline for the project going forward. Just to give an example of a project that we've used the carbon assessment tool on, we were looking at, this is the structural design of a swimming pool, and we were looking at changing the roof of that pool and looking at how the redesigning of that can impact on the amount of materials that are used within it. So as the graphic is showing, the changing in the arc depth has a direct impact in the quantity of materials that's used, and then using that information, taking the worst case and the best case in terms of material usage, putting that information into the tool just on this one structural steel element, which you can achieve a saving of 37 tons of carbon for a very small structure. And that doesn't take into account the reduction in the weight of the structure and what that would mean for other materials within, including the substructure. So I think just looking and understanding where materials are being used and what impact that has in terms of the embodied carbon is a really useful output from the tool. But you don't necessarily need to be able to use the carbon assessment tool to be able to do that. This is a project that was done by not using Revit. So the project, one of the core requirements of the client was to consider the embodied carbon impact of the project. So all these 4 designs were design options that were considered, all of them having a central concrete core and then different framing and slab types. All of them therefore having a completely different embodied carbon impact. When we look at this, the output from Revit, where we have put in with the materials lists, we have added in the embodied carbon of the materials. So our system will automatically give us an output to tell us the saving in terms of embodied carbon. As you can see to the right side, each of the schemes has very different in terms of materials quantities, and then also in terms of the tons of CO2. And obviously scheme D, which is a timber structure, has the best performing, but it wasn't chosen as the most efficient in terms of embodied carbon, but it wasn't chosen as the design that was taken because other considerations were made, such as structural efficiency, cost, materials, and ease of construction. But even looking from scheme A to scheme C, there is a saving of around 5,000 tons of carbon, which is substantial, even if you don't go all the way to a timber structure, which would give you the most saving. So once we've looked at the design and optimized the design, then it's about looking at it in terms of how we can reduce the impact in construction. So it's about building efficiently. The design really does influence how a contractor can build a project. So considering the construction and streamlining that process in the design can also help massively when it comes to construction in terms of saving embodied carbon. And there are additional ways through material selection and sustainable site management that can also reduce the impact of the carbon impact of the projects. So if we look at something like, I'm looking just purely at material selection and reduction. If you look at this graphic on the left side, you can see that by weight, cement makes up 14% of the concrete. But taking the image on the right side of the graphic, it shows that actually the impact in terms of embodied carbon of that cement, 14% of cement has, is huge. So looking at ways of being able to replace that cement by GGBS or fly ash and other products that are being developed really can make a difference. And making choices in terms of the specification of the material is a good way of being able to minimize embodied carbon without having to change the design if it doesn't enable a lesser embodied carbon product at the end. Obviously, governments, building departments have their own requirements. Here in Hong Kong, we are limited by how much cement replacement we can use because of building code. But there's a lot of innovation and research going into it globally, and hopefully we can start to see some replacements coming into Hong Kong, as well as how it's used globally in other countries. There is also obviously using less steel is great, but actually looking at it in terms of using better steel. Steel there's two main manufacturing processes for steel. One which by nature uses a large quantity of recycled content. And that has a massive impact on the embodied carbon, as the graphic shows. I also wanted to show that different countries have very different embodied carbon impacts in terms of the materials that are used in their building. So in Hong Kong, when we look at high recycled content steel, it's around 1.3 kg of CO2 per kilo. Whereas in the UK, it's possible to procure, the embodied carbon is much lower and less than a kilo. So it's important that the data is representative of the country as well, and the supply chain as a means of really understanding what impact that can have. And then looking at modular construction or kit of parts. So the major use of embodied carbon in buildings is in the superstructure. So if it's possible to look at modular construction for many other reasons than just embodied carbon, but just by doing that, there is on average 10% less carbon involved by the nature of the way that the materials are produced. Tend to also be a lot less wastage on site, and it's also easier and quicker to build. And then finally, looking at good construction management practice. So obviously every construction site is very individual and has a lot of constraints that impact on its ability to be able to deliver low carbon construction. But there's always opportunities and innovations that can be implemented and used on projects. If we take, for example, early connection to the grid is a great way of being able to reduce energy. But if that's not possible, then looking at having high performance generators or hybrid generators that can use biofuel instead of diesel, looking at setting idle timers, just all different ways of being able to reduce those carbon emissions. Along with waste and looking at waste not as an end product, but as a product for something else. So looking at ways to, first of all, reduce the waste, but then look at other outlets for it rather than it ending up in landfill or being sent for recycling. Then another thing is the use of BIM. Using BIM on projects can also help again with modular construction, but it can also help in removing the need for abortive works. We often have in Hong Kong, abortive works are quite common on projects, and we know you can really see the impact that that has in terms of wastage and therefore embodied carbon. And then finally, looking at the site office and site accommodation, it's a small energy consumer in comparison to everything else going on site, but it does have an impact. And so trying to make those as efficient as possible, which improves the thermal comfort for both operatives and also therefore the overall performance of the site. So to conclude the presentation, embodied carbon is becoming a more significant issue for the construction industry as a result of improving operational performance and decarbonization of grids globally. Legislation is evolving and the systems being put in place in various local authorities or government organizations to drive people to think about this. And the supply chain is becoming engaged. On this project, we worked heavily with the supply chain in Hong Kong, and the initial meetings we had, there was interest but not really knowledge about what we were talking about and what we wanted to achieve. But through engagement and working with them, we managed to get information, and they managed to be able to, in turn, hopefully influence up the supply chain to the manufacturers to drive this change. Data is available, and we can now develop understanding of what we can do and what reductions can be achieved and how best to do those. But again, any country will need to have its data that's relevant to its construction processes and methods and types of building, and therefore understanding that and getting that information is vital for us to be able to move forward. The earlier we start the process, the better. Design decisions really affect the ability of projects to reduce and achieve embodied carbon reductions. So engaging through the whole supply chain project life is really important. And the World Green Building Council have set 2 ambitious targets in terms of embodied carbon by 2030 to hit this 40% reduction, and then long term to align with the net zero carbon, whole life carbon. So now's the time to really start to get the information and to drive the industry forward. Okay, thank you very much for listening.
Thank you, Jonathan, and thank you, Helen. So we have a few questions come through. So firstly, we'll have, hi, do you think embodied carbon benchmarks used by the industry capture accurately the transportation-related impacts of getting materials to site, for example, taking full account of the fact that some building components may have traveled internationally several times over during the manufacturing and assembly process?
So I'll take that one. If I give context to what we've done in Hong Kong, so life cycle assessments, environmental product declarations declare the emissions of the transportation of the material from extraction to the end of manufacture. So the cradle to site gate, manufacturing gate. And so those emissions on the whole are very well captured. The transportation emissions from manufacturer to site is, as a percentage, quite low in terms of the actual total embodied carbon of, if you look at the materials life, like upfront life. So we did capture it. We assumed different modes of transport to get to Hong Kong and within Hong Kong. But again, knowledge is power, and understanding and working with the supply chain to actually get the right data. But its actual contribution is quite small when looking at the overall total embodied carbon from A1 to A4, so for when it gets to the site to be installed.
Thank you, Helen. So another one came through. Jonathan, do you want to add on to it?
Yeah, and also say, if you are relying on standard numbers or database to calculate the embodied carbon for a project, then the results might vary, because say when you trying to find a embodied carbon for example, a certain grade of steel, the database not necessarily reflect where's the material actually come from. So in that case, yeah, the result might not capture everything, but if you got the exact environmental product declaration certificate for a particular product, it's normally very well captured for their footprint.
Thank you, Jonathan. So another question came through. Helen, so you mentioned timber schemes in your presentation. The figures are very impressive. Do they include timber sequestration? How would the figure changes if a whole life carbon approach A to D were taken?
So carbon is a super contentious issue in embodied carbon. You often get, the figures in the example I showed does include sequestration, but often you'll get negative values for timber based on that. And so I think that within the embodied carbon world, it is one topic that is hotly debated, more so than any other material, as to how you should deal with timber in terms of its whole life. So, yeah, so I think that's one to learn from.
Great, thank you, Ellen. So one more. Isn't there a dichotomy between the desire on the one hand to make early design decisions that reduce embodied carbon, and on the other, using tools which require very detailed builds of materials from platforms like Revit when all major design decisions have already been made? Don't we need more agile tools that can be deployed much earlier in the concept stage of the design process?
Yeah. So I think that's a really, really good question. But I think the issue is not about the two. Imagine when you're trying to design a building, quite often structural engineers will study maybe 3 or 4 several structural schemes just to work out which foundation and superstructures would be easier to be constructed, which will be cheaper to be built. And when you're at that kind of level, you don't need super accurate numbers. You just need to work on like what are the major materials, what are the general approach, and then you'll be able to compare them. So we can actually use this exactly the same approach when you come to embodied carbon. You don't need very accurate BQ for calculations. You just need to compare 3-4 options just to get you on the right directions. And when your design progress further, then yes, you can use more accurate data to sharpen the pencil.
Great, thank you, Jonathan. So there's another one. Where would you recommend to find information about materials that have a lower embodied carbon value?
So there are databases, international databases, which can give you that kind of information. If you look at it in terms of steel, then there is the World Steel Organization actually has a really great database for steel products, and that can tell you they work very hard to maintain that database and share that information. So from that perspective, that's a good one. The life cycle assessment tool by EC3 also has materials that have different recycled contents, different, obviously same performance, but different recycled content. So that's also available to use. But I think environmental product declarations from the manufacturers are the best way to understand, and they are available. And they are, if you approach manufacturers, they have them, a lot of manufacturers, more so in Europe than, but yeah, there is a lot of information available. It's just about finding the right person to ask.
Yeah, and also another alternative way to look at apart from good database is that sometimes when you go straight to suppliers asking for embodied carbon information, they might not have that information ready. But if you ask them, say, which product got higher recycled contents and locally made, those products normally would have lower embodied carbon at the first place. So you can use that as a starting point as well.
Yeah, sometimes actually talking about embodied carbon doesn't necessarily get you the answer that you want. So Jonathan's very right. If you go in there and ask them about the makeup of the product or all that kind of information that they know about their product, then it can lead you to make different decisions and ultimately understand the embodied carbon. But it's about talking around it to get to the right point.
Thank you. I think steel is a definitely interesting topic here. We have another question about steel. So someone commented, interesting point on the recycled versus virgin steel. Are there significant cost differences, or are they readily available? Are both readily available?
Yeah, so I'm trying to explain that from perspective of Hong Kong or China perspective. So we have a very interesting situation when we talk to manufacturers or suppliers. They actually don't want to let us know the recycled contents in their steel, because their perception is that if I got high recycled content, which means my quality is lower. So virgin, their concept is that virgin still got better quality and they can sell you for a premium. So which means over here in this part of the world, we're actually not paying premium for materials with good recycle level.
Yeah, I think it's very much dependent on the manufacturing location. So if the for instance, within the Middle East, there is a lot of much higher recycled content in steel by the nature of the location and its access and availability to that recycled content steel. So the price, from what we've seen, I mean, it's obviously different in Hong Kong, but we haven't looked at it globally within our team, but we didn't see, there is no major price differential, and often it's supplied to our sites within Hong Kong actually as mixed loads. So that was something that we realized, that you get high recycled content and low recycled content in the same load because suppliers buy globally and hold it in Hong Kong and then distribute it. So I think we hadn't noticed in Hong Kong that it has a price differential.
Great. So one more question. Many companies choose to carbon offset their emission instead of going through the WLC process. What are your thoughts on that?
Whole life cycle.
Oh, yeah, okay.
I think that personally, offset is a way of doing it, but it depends on how long you look at that. Offsetting it once is fine, but often can actually be a lot more expensive than looking at better or different procurement of materials. I personally feel that stopping it rather than offsetting it is better, but if it's not possible, then obviously offsetting it serves a purpose.
Yeah, I mean, offsetting it's not the most direct way of doing that, but at least it's doing something positive elsewhere in the world. So I think we will encourage people, like Helen says, to reduce our embodied carbon at the first place first, and then for the rest, I mean, once you start offsetting carbon, often your long-term goal is also to reduce your reliance on carbon offset as well.
Great, thank you.
Just to jump in there, Elaine, we did actually do a webinar on this a couple of weeks ago, and Madeline was talking about offsetting and some of the different companies that you can use and ones to look out for. So if anyone's interested in finding out more information on that, there is a previous webinar.
Yeah.
Yep. Thank you. So we're just mindful of time. We would love to get through all the questions today, but we'll just do one last question now. And for those who have asked the questions we haven't get around to, we'll get in touch with you with an answer afterwards. So the last question is, what's your experience with CLT and the whole of life approach?
Everyone wants to know about timber. Unfortunately, in Hong Kong, we're not able to even do timber buildings. There is no, it's not allowed. So we don't actually have personally that much experience of timber buildings. We are looking at a project in Japan, which was looking at a timber building. And the availability and the actual impact that it can have in terms of reducing the embodied carbon is substantial. And actually its structural performance for so what we term low rise in Hong Kong, but like over 12 stories. So it's, we build much taller buildings. So it's, I think there is many benefits to using timber. And in Japan, it's a standard way of building homes. So We just unfortunately can't do anything like this in Hong Kong, so
Yeah,
we don't. It's not included in the tool either, because
yeah, we've much more experience in the UK, so I'm going to pass this question on to Lee Leston Jones and let him go back with the answer. The person who's asked it, I mean, that's what we might as well do, is join up our global knowledge.
Yes, definitely.
And something we need to learn more about, because I say if we want to work in France, the government there are mandating that 50% of all public buildings have to be of timber going forward. So it's definitely a very fast developing area. Yeah.
Great, thank you. So thanks for all the great questions. That was our last question. I would like to thank take this opportunity to thank our speakers today, Jonathan and Helen, and thank you, Thomas, for joining us this morning. I would like to also thank everyone for joining us in this webinar. As Thomas and Helen mentioned earlier in this webinar, this is the last session of our second series of webinars. And if you miss any, or if you would like to share the recordings with your colleagues, we'll upload this webinar onto YouTube and send a link around to you all. Thank you very much for joining us, and have a great day ahead. Thank you.
Thank you.
Thank you very much.
Thank you all, and we'll see you in the next series.